basically building up to it to be able to get that. Does that make sense now, sir?
Because I did that, I think, I kind of like.
That's okay, but you're good now.
Yeah, I get it, I get it.
Okay, that's all right. All right, other questions, guys? Okay, so one way that we can show that two statements are equivalent is being able to use a truth table, okay? Because if we take two statements and they have the exact same truth tables, that means they must be logically equivalent, okay? So, basically, two statement forms are logically equivalent. And by the way, when you see IFF, that doesn't mean I spelled it wrong, but does anybody know what IFF means in mathematics?
If then thens, right?
Not if then else,
If it's testing equivalency.
which means, you're right,
It's a two-way, right?
it's not biconditional, but
If and only
if
And
and
only,
only if.
yeah.
Okay, so whenever you guys see this, okay, this might be helpful, because we're going to be using this quite often. If you see IFF, that means if and only if. Okay. So if some of you guys ever have, if you got some of you guys who might be math majors and you have to take like abstract math or abstract algebra, they use that all the time. Okay, so I just want to make sure you guys are good with that. So I want to prove or disprove the following using a truth table. Okay, so we have P and Q or R is, when we see triple equal means logically equivalent. Okay, so when you guys see this guy, again, it's just that I wasn't drunk and made up one more line than I should have. This just means logically equivalent. So logically equal. Yeah, as if my handwriting isn't bad enough. And I put it on the smart board, it looks even worse. Okay. At the end of the course, we're going to look at geometric equivalencies, like isomorphisms. It's the same thing, like logical equivalence. All right. Guys, if I want to show that these two statements are logically equivalent, which they are, I can use a truth table. Okay, so that's what I'm going to do. All right. So what I'm going to do first is, I have my truth table over here. I just erased everything. It still has 3 lines, or I'm sorry, it still has 3 variables, which means we're going to have 8 rows in this. I'm going to build a truth table for the left side, then I'm going to build a truth table for the right side. Okay, so what I'm going to do is that this is going to be LHS, or the left-hand side, okay, and then I'm going to have something for the right-hand side. All right. If I'm looking at the statement form, I notice that I have P and Q in the parentheses. So like we said, guys, always start in parentheses. You can't go wrong if you start there. Okay? Didn't we already say that for that to be true, both P and Q must simultaneously be true? So just like before, isn't it true that only rows number 1 and 2 are true, and then the rest of them are false? So this is going to be true, true, and then a bunch of falses. My next column, if I'm looking at the left-hand side, should just be P or Q, or I'm sorry, P and Q or R. Okay? So this is going to be P and Q or R. The first 2 rows have to be true, okay? Because we already know that P and Q is true in that first row, and it's P and Q, which is true, or something else. Okay? So we already know that these 2 are true. And then for the rest of them, that's when we look at R. Okay? We don't care what P and Q is anymore, because we know that the rest of them are false. So now what I'm going to do is I'm going to look at R, and I'm going to say, okay, well, R is true in row 3, in row 5, and in row 7. So true, true, true. And then I just put falses in the other 3 spaces. Okay, so false, false, false. All right, so this is our left-hand side equivalence. Okay, so does that make sense to everybody, guys? All I did was basically the same problem we just did for the last 20 minutes, except I just looked at the left-hand side. Okay, so now, if we're looking for equivalence, what we have to make sure is that it's equal logically to the right-hand side. So now what I'm gonna do is I'm gonna build the right-hand side, and if they are the same, they're logically equivalent. If they're not the same, that means they're not logically equivalent. Okay, so for our right-hand side, again, we start in the parentheses, so I have a P or R. And then I also have a Q or R, I believe. And then the last thing I'm looking at is I'm looking at P or R and Q or R. Okay. So before I go on, I just want to make sure everyone's okay with why I'm setting it up this way. Okay? Does everybody understand that the reason I'm setting it up is because I want the left-hand side and the right-hand side, and I want to compare those two. Because if they're the same, that means that these are logically equivalent. So I'm just building it, just like we did in the other two problems. I'm doing parentheses, and then I'm doing like the connector between those.
So the last column is the right-hand side column?
That's correct. This guy right here is the right-hand side. And essentially what we're hoping is that these two are the exact same. Okay? If those two are the same, that means that the statements are indeed logically equivalent. Okay? So now it's just up to us to be able to fill that in. Okay? So P or R. Well, remember, guys, either one of these can be true. So I know the first four are going to be true. And I know that when R is true, so that would be rows number 5 and 7. And then the other ones are false. So like I said, guys, the sooner you guys memorize those 4 initial tables, the easier it's going to be for you guys to fill out the rest of it. Okay? For Q or R, okay, so now what I'm doing is I'm just looking at these two. And remember, Q or R means that one of the two has to be true. So it looks like row 1 is good, row 2 is good, row 3 is good, row 4 is not good, 5, 6, 7 is good, and then row 8. So basically everything except for row 4 and row 8 are going to be good. So we have true, 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 false, true, 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 false. All right. Last thing we have to do is we have to look at the last 2 columns that we have there. And then hopefully those last 2 columns, when we do the and between them, because what you'll notice is it's P or R and Q or R. So now all I'm doing is I'm just taking these last 2 rows and I'm just kind of melding them together and seeing for the and. Okay? So can somebody just go down the list and tell me what the last column should look like with the truth values for those? Go ahead, sir.
True, 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 false, true, false, true.
True, 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 false. True, false, true, false?
Yeah.
Okay, thank you, sir. That looks good to me. So, true, 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 false. Okay, now remember, for this to be correct, both of those must be true. Okay, so, true, true, true. And then as soon as you see a false, that output is false. Okay? Same thing, true. So row 5, row 6 is false, row 7 is true, and row 8 is false as well. All right, now we actually need to answer the question, and the question is, are these logically equivalent? Well, I take a look at this column. I take a look at this column. Okay. And I want you to notice that row 1, 2, and 3 are true, row 4 is false, row 5 is true, row 6 and 8 are false, and row 7 is true. So they have the exact same logical outputs, which means that it is a true statement. Okay, so this is valid by truth table. Okay. What we actually did was I gave you guys this handout that we didn't use today. Okay, but I want you to notice under the basic logical equivalencies, okay, that this is actually one of the distributive laws. Okay, so if you go down to distributive law and you take a look at this, I guess it's going to be the second one. where we have P or Q or R. I know the letters are a little bit mashed up, or not matched up necessarily, but it's exactly what we did was we actually proved the distributive law in this, okay? And the most fundamental way to prove these logical equivalencies is to be able to use a truth table, okay? So that's why we're actually looking at these, so we can prove these. And next time we're going to be able to use these to be able to prove more difficult statements. Okay. So, next time what we'll do is we'll do that last problem that we have. Then we're going to start looking at the Boolean algebra stuff, which a lot of students don't like too much. Then we're going to start taking a look at maybe some of these argument forms as opposed to statement forms. Okay, sir?
Generally speaking, for the sake of this class, will we be only working with these statements?
Yes, I will not, as long as you guys don't piss me off, I will never give you more than 3 statements, which I don't necessarily see that. Okay, plus that means, bless you, that's twice as much I do anyway, bless you again. Okay, so other questions I can answer. Okay, so assignment 1, you guys should be able to do like maybe the first half of that assignment. Generally what I do is I go through 2 classes and then an assignment's due. So I'm guessing assignment number 1 is going to be due not next Monday, but next Wednesday, because next Monday we're not going to be on campus, right? So I'll post this in Blackboard for you guys, but there's nothing due next time, but you might want to work ahead of it.
Is this assignment 1 the one we are doing?
No, sir, assignment's posted on Blackboard, okay? But that is the material that you need to be able to do.
Okay.
All right, go ahead.
The assignment submitted online, or we print out paper?
You just print out a paper copy and then you just give me the paper copy on separate paper, okay? All right, guys, if there's something you guys need from me besides money or psychological help pulling up, I'll try to help you out with that, okay? If not, then I'll see you all on Wednesday.